So now we're dealing with, well, we're doing with the empirical rule, so we don't have to worry about the normal curve calculator. But we're dealing with two different things here. We're talking about the whole distribution of cigarettes, of nicotine in cigarettes, and then we're starting to talk about samples. So this is the sampling distribution, and we have to worry about that central limit theorem. So for the first part, let's see, they're telling us that the nicotine in cigarettes has a mean of 0.967, and that's the middle, normal distribution, so 0.967. And then we want to, since we're using the empirical rule, I'm going to draw my picture just a little differently so I have some room to write. I'm going to spread this out a little bit. Okay, and I'm going to draw 3 lines going up and 3 lines going down. And then what I'm going to do is I'm going to subtract, well, first I'm going to fill to the right. So I'm going to add the standard deviation 3 times, so 0.281 plus 0.281 plus 0.281. And you have to bear with me while I crunch this on my calculator. So 0.967 plus 0.281. I've got those numbers, yeah. 1, 2, 3. So this tells me the nicotine here is going to be, not why'd I do that? Guess I'll type. So 1.248. I'm going to
So when I read this kind of problem, I notice a couple of things. I notice that they tell me a percentage of leaving that population towards the population percentage. And I notice that I better sample. So that flags me that the sampling distribution situation going on here. So then I'm going to ask myself, well, let's see, is this a binomial distribution? So either customers, there's 28% chance that any single order came from the first 10 customers. So yes, no situation, first 10 customer not. Probability case change, customer to customer. That's 6 number of trials, 147. And I would think that any one of these orders are intended to each other. So it is a binomial distribution, and we would expect sample size distribution. 177 times 28 greater than 10, greater than 10. Well, I'm pretty sure it is. I know 10% is 17, so it's 28%. So I'm golden there, and then the same thing, I find the converse of that or the not, what is that, 272? 272 times 177 also greater than 10%. So it looks like the central limit here does apply. I can use the normal solution here for the learning. So I've got the center of 0.28. I've got a standard deviation of 0.28. Times 1 minus 0.28, which is about 0.72. Over the sample size of 177, and I take the period of that. So the calculator is telling me this is about 0.0337. That's the standard deviation. They want to know what the probability that the random sample of 177 orders will have a proportion of less than 0.32. So that 0.32 is about there. And I want to know less than that. So this is just a normal CDS situation where the mean is 0.28, the deviation is 0.0337, and I want to know less than 0.32. The results from my calculator, I got the 0.882, and that agrees with my math. So that's how you do it. In the David Lang, we said up to